Good morning. I'm Christine Sa. Welcome to this news briefing from the 250th National Meeting and Exposition of the American Chemical Society in Boston. We're joined today by Ellene, Tratras, Contis, and Isai Urasa, who are with the ACS Committee on International Affairs. They will be talking to us about the ACS Global Innovation Imperatives program, which has just released a white paper on best practices in water treatment. Ms. Contis.
Good morning, everyone. Yes, we were very fortunate to be able to put together a white paper from the Gii program in Singapore at the beginning of December 2014. The Gii program is solely under the auspices of the American Chemical Society, and it chooses an imperative. In this case, the imperative is water, and specifically the idea of drinking water, which is very scarce around the world. So we went to Singapore at the beginning of December. We had what is called a forum, a water forum, from December 3rd through the 5th. And during that process, what we did was to actually have presentations by people from Singapore and people from the American Chemical Society, ranging from all kinds of water treatment and drinkable water filters and so on around the world. We met and had an open forum, a presentation forum. Everyone was invited to attend. And we heard from the ACS speakers and the Singapore speakers. The focus was on the Singapore water story. It's a very unique system. Singapore is a very small country, and they actually have 4 ways of acquiring and dealing with water. And so the white paper is based primarily on what we found in Singapore and how the ACS speakers, in terms of some possible local solutions, added to that forum. Singapore has 4 water taps, local catchment, they do desalination, they import water, and most importantly, they recycle all of their water. That's all of their water, and they formulate it into what's called new water, and that was very interesting for us. The second day we went to a desalination plant, one of the largest in the country, certainly the largest in the country, but one of the largest in the world. And that is run by GE and also by a very important company, Flux, which in fact generates a very interesting desalination process and filters that allow seawater to be brought in and made into fresh water. We also went to one of the largest reservoirs that Singapore has. That's called the Marina Barrage, where they actually have captured a lot of water and are slowly creating fresh water from the seawater that's just on the other side of the dam. So that's very interesting. So all of that information pretty much was put into a white paper, and the lessons learned was that basically we can in fact do local solutions from very global water issues. And so the information that we acquired there, along with information from the ACS speakers, helped us put together this white paper.
Okay. Isai, would you like to add anything?
Yes, I'd like to add to what Ellene just said. We went to Singapore, particularly because of the story that she talked about. Singapore has made considerable progress in the last 50 years in the area of water resources. In fact, I say that when you look at Singapore, what Singapore was back in the 1960s, is where some of the developing countries are today in terms of the water resources. So Singapore has made considerable progress in addressing the issue of the resources. And of course, that's primarily because of the nature of that island nation. It's an island nation that doesn't have much water resources, so they have to rely on seawater, they have to rely on rain. And of course, the most intriguing thing was the ability to recycle water. I think, to me, that was the most interesting thing, and particularly what they've done to make the local population to accept that what they call new water. This is recycled water, and as you might expect, there are some social kinds of issues related to using recycled water. I think that the ability to desalinate water and the technology that they have developed over the years is something that I think can be emulated in other parts of the world. Let me also say that when you look at water resources, Personally, I think that there are two requirements here. Number one, clearly there's got to be new technologies developed, and that in itself is not sufficient. New technologies must be coupled with stakeholder involvement, stakeholder acceptances, and so on. So these two components have to work together in order for any innovations to be successful. And again, here I think that the Singapore story is a story that can be emulated. As we all know, there are water threats. Water is a scarce commodity around the globe, and therefore we must do whatever we can to make sure that whatever little we have, it is properly used, and that we continue looking for new sources.
Okay, thank you. Do we have any questions?
So it's Kath O'Driscoll from Chemistry and Industry magazine. I'm very interested in the new water idea. Can you tell me a little bit more about the technology that's involved in creating this new recycled water? And also you mentioned social acceptability. What was actually done to involve people and to make them aware of what this actually was?
We didn't really get the details as to how people, the local community was made to accept the new water. I must add here that this is not 100% acceptance, but clearly that new water is accepted, it's being used. In fact, I brought 2 bottles myself back to my laboratory back in Hampton, Virginia, where I'm a professor and I do analytical chemistry research. And I have those 2 bottles, and what I plan to do is to look at that and just to, to take it from there. So again, to answer the question, we didn't get too many details as to how the local community accept the new water. We know that it is being used. I don't know if Ellene got some more information on that.
Right. It was a very important and very long and involved and very researched public campaign because, of course, people thought, no, there's no way. The 4 taps of water are all brought in together, and they are mixed according to how much they generate and how much is imported and how much is desalinated and so on. So it winds up being probably less than a quarter of the total water that they actually send out for drinking water purposes. They showed us a list and they showed us a diagram of all of that, but their process is fairly proprietary. They have, in fact, put together a very detailed collection system for the water that's been used, and it all goes kind of into one pot. So underneath Singapore, there are these huge tunnels and conduits in which water is collected, and based on the analysis of the water and the treatment of that water by various means, they then process it and bring it back into regular drinking water. So it's a fairly complex, very engineering-wise, very important aspect that they're working on. So it was very impressive, but also proprietary.
Thank you. Desalination has a certain energy intensivity to it. Was there anything unique to Singapore's approach that began to speak to or address or think about energy balance issues with that particular process?
We asked those questions, and they seem to have resolved them. Again, not necessarily forthcoming with every item, but they are picking up water from the sea nearby and then letting the salted water out at some other point. And they claim that there is no change in the ecosystem. And they basically explained to us how, so that we were all satisfied in that respect. In terms of energy, it is a process whereby they actually are simply pumping water in, and these unique filters that GE has put, or HyFlux has put together, are long tubes, almost like strings or threads. The water is pumped through there, and in that process, it's an osmosis, a reverse osmosis process. So it's a fairly high throughput, and it appears to not have a lot of energy required except for the actual pumping in of the water. So that's quite unique.
Another thing that is interesting in that regard is the fact that the desalination process is coupled with intensive research, particularly membrane development. Again, here, reverse osmosis is the process being used to desalinate water. And the efficiency of that process depends on the membranes that are used. So they are doing considerable work in that area to develop new membranes. So membrane technology development is part of that process. And clearly, and you are right, that the water energy nexus is something that's to be looked into. There's a lot of energy used to desalinate water, and the efficiency of the membranes and whatever devices are used will make a big difference as to the energy requirement of that desalination process.
Go ahead, Doug.
Doug Dollamore, Science Elements Podcast. You mentioned that this has been a 50-year process in Singapore, and with climate change and the developing long-term drought in our agricultural states of particularly California and Arizona, how long does this process, getting sufficient numbers of desalination plants up and going so that perhaps we can mitigate some of the drought effects?
Well, climate change is the big elephant in the room, isn't it? Because we really don't know the impacts of climate change. We do. Maybe not every one of us, we have accepted the fact that there is such thing as climate change. And climate change is affecting a lot of things that we do, including water resources. But the full impact of climate change as far as water resources is concerned is yet to be determined. So when we look at the threats, the spectrum of threats to water resources, clearly climate change is one of them. There are others, water use practices and population growth and urbanization, urban growth, and so on. Those are threats. Contamination is another. But climate change is the new elephant in the room, as I said, and the full impact of that is yet to be realized. And I think that, to me, and California is an interesting case. And personally, I'm very much impressed with what's going on now in California to really change behavior, particularly as far as water use is concerned. And that I think with time we're going to learn something from the California issue as it is now.
Well, Singapore is unique because it is an island nation, and they've only been in existence for 50 years. And so they kind of had a head start in the planning process. So I think that's probably why they're so far advanced in terms of the various ways of collecting and working with water, because they know they can't go beyond their borders too much. But the idea of the use of recycled water, I think, is going to be an important consideration down the line, no matter how the climate changes, because it is going to be an important consideration. And the idea, we should look at Singapore for their campaign in terms of converting people into the thought that, yeah, it's okay to use recycled water.
Beyond Singapore, the United States, the rich countries in the world, there are countries that have fewer resources, that have other difficulties that they have to address. I'm just wondering, did you address any talking about how to get the desalination going in those countries that really do need the water but may not have the resources?
We did talk about other types of filtering processes, and Isai actually worked on a project that uses different methods of filtering. It includes bone char. We've looked at other issues where banana peel, so that we're looking at local solutions. That is, we're looking at what do the people have in the area, And how can that best be used, for example, to clean water so they can have potable water to use?
Again, we also should emphasize local solutions to this global problem. The Singapore story cannot be repeated or applied everywhere. Singapore is unique because of what Singapore is. When you look at other parts of the world, where I come from, where I was born, in Tanzania and countries like that, the story is slightly different. Tanzania is not an island nation, but Tanzania has a lot of water-related problems. And what the scientists and the governments and so on are doing in those countries is using available local resources. I was involved in a project that used beef bone char to filter water. That part of Tanzania where I was born and some parts of Kenya and so on, water has very high fluoride levels. And as you know, while fluoride is important for teeth and bones, too much fluoride is not good for you. It can lead to the skeletal fluorosis. And so that's a big problem here, just as an example. And so there's some local solutions that we have worked on using animal bone. Bone char is very effective in removing fluoride from water. So I worked on that project. It was very successful. There are other things being used. And so, again, to answer the question, we want to emphasize local solutions to the extent that those local solutions can be developed to address the problem at hand.
We've got time for one more quick question.
Good morning. I know that Singapore is a small island country and not much arable land, but did they address how they use perhaps water for agriculture purposes or water for purposes outside of drinking water?
Well, certainly they use it for agriculture in order to grow the crops that they have, but they import a tremendous amount of food, fruit, vegetables. They're very close to Malaysia, of course, and so they have reciprocal agreements. And most of their food is actually brought in from Malaysia. Yeah.
And imported water from Malaysia. That was interesting to me. They're talking about imported water. And I said, what's imported water? I was talking bottled water. I said, no, actually water is pumped from Malaysia across the channel to Singapore.
Right.
And that was very interesting.
That was interesting. They actually were permitted to build treatment plants in Malaysia so that they can take the water and actually treat it and then pump it into Singapore. So that's one of the 4 taps that they use. So that was also interesting.
Great. Well, thank you, everyone. The archived version of this session will soon be posted at bit.ly/ACS Live Boston. Please join us for our next press conference today at 10:30 a.m. on the mosquito-repelling chemistry of sweetgrass. Thank you.